In the second set of notes for Module 1A, we have segment addition. And we have that if we use a ruler, you can find the distance between 2 points on a line, and the distance between points A and B, written as AB, and notice there's no symbol above it, so keep that in mind, that is the absolute value of the difference of the coordinates of A and B. So it's the distance from A to B. What this looks like is when we are adding segment lengths together and we have 3 points that are collinear. Remember, collinear means that they share the same lines, so they're on the same line together. You can say that one point is between the other two. When we say that it's between the other two, that doesn't mean that it's halfway between. It just means that it's somewhere between the other 2 points. So for example, if we use this number line and we want to find the distance from A to D, we can count the spacing between it. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would be 9 units. Okay, so for CE, if we do from C to E, we would have 1, 2, 3, 4, 5, 6 units. So that's the basic explanation of the distance between the two of them, or if we're adding them together. But segment addition postulate basically says that if B is between A and C, then we know that A, B, and C are collinear. And since they are collinear to each other, we can add the different segments together. So since B is between them, that means that I can take AB, so the distance from A to B, and add it to the distance from B to C, and that should give me the length of the whole segment altogether of AC. So then B is between A and C. You're going to hear me say this quite a bit, that if we add the pieces together, that will equal the whole segment. So in example 2, when we need to find the indicated length of RT, that means that we can add RS to ST, and that should equal the whole length. So if we add those together, so 17 plus 8.5 should equal RT. So if we add 17 plus 8.5, that gives us a 25.5, and that's the distance of RT. So on this next one, we see that BC is the part that's missing, but we always know that if we add the two pieces together, that should equal the whole segment. And that's how we have it set up. And now we can fill in the pieces we have. So we have 25. We don't know what BC is, so that stays BC, but AC is 54. So if we need to solve this, we need to subtract 25 from both sides. And when we do that, we get a 29 on the other side. So BC is equal to 29. These next two questions work the same way, except we don't just have constants, we have some variables mixed in. But just looking at your picture, we know if we add the two segments together, that will equal the whole segment. That means we have MN plus NP equals MP, so the whole segment, but if we fill in the pieces that we have for each one, so x minus 5 plus NP is 3x plus 2, and then the whole segment is our 6x minus 23. Now we can solve for x. So we need to combine our like terms together, so we get 4x, we have a minus 5 and a plus 2, so that gives us a minus 3, and the right side stays exactly the same. Now whenever we go from side to side, remember you need to add or subtract your variable. So if I want to move my 4x over, and you have to take it away from the left side and the right side, so we end up with a 2x minus 23 on the right. Next we want to move this negative 23 or minus 23 to the other side, so we have to do the opposite of it, which is adding. Then we have 2x on the right still. When we add those two together, we get a 20. But now to separate the 2 from the x, we need to divide by 2. So if I divide both by 2, I get x equals 10. Now make sure you always, always, always read the directions, because we solved for x. So I checked that part off, but now I need to find NP. So if I need to find NP, that is this section right here, so my 3x plus 2. So I have to take 3 times 10 plus 2, so that's 30 plus 2, so I get 32. And now we have both parts answered on our question. This next one is worded just a little bit differently, but you do the exact same thing. So points H, J, and K are collinear. They're just telling us that because there is no picture. So if there's never a picture, you always want to draw a picture yourself. So let's go ahead and draw a line. Now I don't know exactly where those 3 points will go, but it says point J is between H and K. So that means whenever I write where the labels are, that's how I need to set it up. So I need to solve for x, but I need to label my picture. So HJ is 5x minus 4. And I filled in the rest as well. So if you remember, we always want to set up what it looks like. We have HJ as the left segment, the right segment is JK, and that should equal the whole thing of HK. So I want you now to go through and find out what the solution is for x. You don't have to find anything else, just what the value of x is going to be. This is what your first step should have looked like, and then when you combine your like terms together, you get 13x and a minus 14 equals 38. Then remember, you have to move things around. So the x is already by itself, so you'd have to move the minus 14 to the other side by adding it to the other side. So you should have 13x equals 52. And then the last step, you want to separate the x from the 13, or the 13 from the x. So we have to divide, and we get x equals 4. And that's all you had to do in that one question. For these last type of questions, we are going to deal with congruent segments. So congruent, we're going to talk about what that symbol means or what that word means. But we have line segments that have the exact same length are called congruent segments. If we know that one segment AB is congruent to another segment CD, and they are both 5 units long, then we can write it a certain way. So this would be our segment AB, segment CD, and this symbol in between means that it shows that they are congruent to each other. And you're going to see that symbol quite a bit throughout the school year. So what we want to do for the different examples is we are going to plot the different segments that are given to us. So here's segment AB and CD, and it gives us the different coordinates of how to plot those. And then we are going to decide if those segments are congruent to each other. So we have to graph them first so we can count the lengths of the different segments, and then we will determine if they are congruent to each other. So let's see, AB will look like this. So A and B, so draw those two out and connect them together. And if we count the spaces on there, we have 1, 2, 3, 4 segments. I'm just going to put a little 4 right there. So it's 4 blocks across. Now for my point C, goes from -1 up to +4. So there's my point C. D is then -1, 0. So I need to connect those together. And again, I need to count straight up and down. So 1, 2, 3, 4. So this is also 4. Because they are the same distance or same length long, we can say that these two segments are congruent to each other. So we would write segment AB, remember with no arrows. The congruent symbol is like an equal sign with a little squiggly above it. And then my segment CD, we put our CD and then our segment symbol above it. So you can say that AB is congruent to CD because they are both the same length, and that means that they are both 4 units long. Now for this last one, I would like you to do this one on your own. So draw the two segments first, so EF and GH, and then you want to compare the lengths of each of them to see if they are congruent or not. This is what your two pictures should look like. So you can count them out, and we have 2 units high for EF, and then GH we have 3 units high. So because they are not the same lengths, you should have put that EF is not congruent to GH. My explanation then would be because they are not the same length, and one is 2 units and the other one is 3 units.